Today's lesson is a short one, and it is on ratio tables. Ratio tables are a way to visualize equivalent ratios. It's going to help us in our next content area, which is proportions, proportional relationships, and also graphing ratios and seeing the linear relationship between equivalent ratios. And so that's where we're going with it. Let's start with a really simple example. Let's say that we've got boxes of apples. I'm just going to sketch a line all the way across there. And one box holds 12 apples. So now, just like if we were doing equivalent fractions, it'd be pretty obvious that two boxes then would take 24 apples, and three boxes 36, and so forth. We'll fill it out here to 5 boxes. Okay. And this, of course, can go on forever. And let's say we were trying to figure out, though, how many apples could you fit in 12 boxes. Now I know that you guys can use your multiplication facts and come up with an answer to that very quickly, but I want us to learn about ratio tables as a way to visualize proportional relationships, which is why we're doing it, going ahead and mapping it out this way. Let me show you also that depending on how you like to do arithmetic in your head, you might approach this different ways to get to 12. Instead of going all the way out, and of course we could have kept going, counting by ones up here, and counting by 12s down here for the apples, and we would then, of course, get my final number of apples that fit in 12 boxes. But most of you aren't going to want to do a long table like that and don't need to. So let's see how we might use mental math and some of our tricks to get there shorter. So if we have one box for 12 apples, I might start by doubling that and say, well, there's two boxes for 24 apples. I might go back here and I might say, you know what, times 10 is super easy mental math. Times 10. So this is 10 boxes for 120 apples. And that's pretty straightforward. Well, then 12 boxes is just going to be however many fit in 2 boxes plus however many fit in 10 boxes. So we've got 120 plus 24. That gives me 144 apples. So that's one way that we might do that, using addition, doubling and addition, to find a shortcut. And what I'm hoping is that eventually we're going to be able to do this type of thing in our head, so that it'll save us some space and time while we're doing that. Let's say on the next example, I wanted to know how many apples fit in 13 boxes. So I might again start by saying there's 12 apples in one box. And if I double those each, then 2 boxes must be 24. 3 boxes must be 36. And then 10 boxes is 120. Well, now I can simply add the 10 and the 3 to get my 13. So 36 plus 120, it must be 156 apples that fit in 13 boxes. Our next example, we'll say we are counting pencils. They come 5 per box, 5 pencils for one box. And I want to know how many there are in 18 boxes. Okay, so certainly I could count individually: 1 for 5, 2 for 10, 3 for 15, 4 for 20, and so forth, and go 1 all the way through 18. But that would be a long ratio table that I don't think is necessary for most of us. So let's take a couple shortcuts. Depending on how you like to get to 18, you might go from 1 first to 3. And then that would mean 5 goes to 15. We've multiplied them both by 3. And then we might multiply them both by 6 to get to 18. So 15 times 6 then is 90. And there's 90 boxes, or 90 pencils in 18 boxes. You might also do this a different way, depending on how you like to get 8 to 18. Maybe you go straight to 9. So we multiply 9 and multiply by 9, you get 45, and then we need to double them to get to 18. So you get 90. Those are two different ways. You can do the ratio table to find out how many pencils there are in 18 boxes. sometimes we might use division. So let's say I have 120 baseballs to divide amongst 8 teams. So 120 baseballs for 8 teams, and I want to know how many baseballs each team gets. So in this case, we want to divide, and we can start by going in halves. So there's 60 baseballs for 4 teams, and then 30 baseballs for 2 teams. So there's 15 baseballs for every 1 team. That'd be one way to solve that. And the last one, if I know that there are 15 cherries for every 1 basket, and the question is, how many cherries are there in 8 baskets? Well, we could double, 1 to 2 to 4 to 8. Let me just show you a different option depending on how your mind likes to work. You might also multiply by 10, because that's really easy. 10 baskets, 150 cherries. We want to know what 2 baskets is worth. That's pretty easy. We double it from 1 to 2, so 15 to 30. And then if I want to know how many are in 8 baskets, that's simply going to be 10 minus 2. Gives us 8. So 150 minus 30 gives us 120 cherries in 8 baskets. Your homework tonight is posted online, and there are a series of tables to fill in. You don't need to write out the problem and a fancy grid box or anything. You can sketch it out just the way that I've done here in our notes. And if we're asking you to complete ratio tables by doubling and by halving. You can see that it's linked on our web posting. And like I said, the idea here is that we're going to be able to visualize how these ratios are going to work. It's going to help us comprehend proportions and graphing rates, which is coming up next.